Hey everyone, and welcome back to the channel. In system design, we often talk about scalability, availability, and performance. But there is another crucial concept that's equally important, which is data integrity. How do you ensure that the data you send, store, or receive hasn't been accidentally corrupted? This is where checksums come into play. It's a simple yet incredibly powerful concept that, when brought up in a system design interview, showcases a deep understanding of robust data handling. Today, we are diving into what checksums are, why they are matter, and where they fit into your system design. So let's start with what is checksum. So what is exactly checksum? A checksum is a small fixed size value that is computed from a block of digital data. It's like a tiny fingerprint or a summary of that data. The primary purpose of checksum is to detect accidental errors or corruption that might occur during data transmission over a network or while data is being stored on a disk. Okay, let's try to understand the basic idea. Have a look at this example. So we have a sender or a writer. When data is sent or stored, a specific algorithm, which is the checksum algorithm, is applied to the original data to produce a checksum value. This checksum is then transmitted or stored along with the data. And after that, we have the receiver. When the data is received or retrieved, the same checksum algorithm is applied again to received data, to the received data, okay? And after that, we will do some sort of verification. So the newly computed checksum is then compared to the original checksum that came with that data. If the two checksums matches, it's highly probable that the data has arrived intact and uncorrupted. If they don't match, it means the data has been altered or corrupted somewhere along the way, and appropriate actions like, for example, retransmission can be taken. Okay, so you can see this example. We have an input like for something like Fox. We put it through a checksum algorithm and we got specific value. And after that, when we try to read the Fox again, we will do when we are doing our verification, we will put the checksum value and we expect to get the same value as Fox. So this is how it works. It's a pretty simple way, but it has a huge benefits. Okay, so let's start to understand why it is that important and why it is matters. So first, it's core data integrity. Like the main role is to ensure that the integrity of data. Without them, you might silently be operating on corrupted data, leading to incorrect calculations, broken features, or even security vulnerability down the line. Number two, detecting accidental corruption. They are excellent at catching random, non-malicious errors. A bit flip due to I would say due to like maybe some like electromagnetic interface, or maybe a faulty memory chip, maybe a bad sector on hard drive, or maybe a packet loss on a network, because there is a huge number of accidents that could cause data corruption. Number three, efficiency. Like checksum algorithms are typically very fast to compute, making them suitable for high throughput systems with minimal overhead. This distinguishes them from like cryptographic hashes, for example, which are designed for different purposes and are much slower. I will not go through what is a crypto hashes right now, because I guess cryptographic hashes right now, because I guess it's beyond the purpose of this video, and I guess you will not face them in your system design interview at all. Next we have ubiquity. Ubiquity. I guess I'm pronouncing it right, because I have this problem with pronouncing things in the wrong way all the time.
Ubiquity.
Ubiquity, not ubiquity. Ubiquity. Okay, so we have ubiquity. So you probably interact with the checksums. I would say it is everywhere. Ubiquity means that something is everywhere. Okay, so you probably interact with checksums constantly without realizing it. They are built into network protocols, file systems, and storage devices, and understanding them shows you know what happens beneath the application layer. Okay, we will talk about some common use cases in system design, and I would say that you need to focus on this section. You will use them in network protocols, you will use them in the TCP/IP headers, like TCP segments and IP packets. Often includes checksums to ensure the integrity of the header information as data travels across the internet. Also, you will use them in file storage and downloads. Like when you download a large software binary, the provider often gives you MD5 or SHA checksum. You can compute the checksum of your downloaded file and compare it to ensure the file wasn't corrupted during the download at all. The file system as well use checksums to detect silent data corruption on disk. Cloud storage services heavily rely on checksums to ensure data integrity across their vast storage infrastructure. Next, we have it is used in database systems and replication. Like database inherently use checksums to verify the integrity of data blocks on disk before writing a block. A checksum is computed upon reading. It's recomputed and verified. Yeah. Also, database replication. In database replication, checksums can be used to periodically verify that replicated data is consistent across primary and replica nodes, catching subtle corruption that might occur during transmission. So let's talk next about how you will talk about checksums in your system design interviews. So in a system design interview, you need to bring up checksums when discussing data integrity. Okay, like for example, if you are designing a distributed storage system, you might say, to ensure data integrity against silent corruption, we will implement checksums on every data block stored and verify them on read. For replication, also you can say we will use a checksum to verify consistency between replicas. This demonstrates attention to detail and robustness in your system design. So again, in your system design, when you want to mention checksum, that make sure that you are talking about data integrity, because this is where it shines and this is where you will use them in your system design interviews.